Welcome to our video tutorial for DeltaMS. This is Nico Überschar from the mass spectrometry platform of the Friedrich Schiller University Jena. In this video tutorial, we like to guide you through our computer program called DeltaMS. After a short introduction, we will show you how to install DeltaMS on your computer, and finally, we will show you how you can perform your own analysis. As you might know from the classroom, in mass spectrometry, for compounds, usually a series of peaks can be observed. These peaks are called isotope peaks and belong to isotopes like carbon-13 or sulfur-34. They have a distance to the molecular ion of 1, 2, and so on. Since the introduction of high-resolution mass spectrometry, these peaks can be resolved, and for example, the M+2 consists now of 4 main peaks, including the elements sulfur, carbon, nitrogen, and oxygen. In principle, we can go also the other way around and look in a spectrum for a pair of peaks with a specific mass shift and intensity ratio to search for sulfur-containing compounds, for example. This approach is not limited to sulfur, because a lot of elements have specific isotope signatures or patterns, for example bromine, chlorine, selenium, iron or molybdenum, or many more. Our program, based on the well-established XCMS pipeline, including peak detection, retention time correction and grouping. As next step, we use the known X13CMS tool, because this can detect the element-specific mass shifts. Finally, we are further analyzing these data using an intensity-based filter. Furthermore, we enable also more experimental setup, which we will introduce later. To make our tool usable for non-R programmer, we implemented everything in a user-friendly graphical interface. Next, we like to show you what kind of experiments you can perform with DeltaMS. Our first experiment are called isotope signature. You can analyze your sample for the presence of bromine-containing compounds, for example. A further possible analysis we covered by case study 3 described in our manuscript. We investigated iron-containing substances, in detail siderophores of a fungal extract. Therefore, we supplemented natural iron to our extract and measured the mixture with LCMS. As you can see, we have an example of a found putative siderophore in our extract on the basis of the specific iron isotopes 54 and 56. But the iron pattern is not very remarkable. Therefore, we performed an additional experiment where we added the pure iron isotope 54 and 58 in a 1:1 ratio to the fungal extract. As a result, you can see a much clearer and easier to interpret mass spectrum. Additionally, a similar experiment was performed containing each of the isotopes in a single vial, which have been measured also individually. With our dataset comparison option, we can also analyze this type of experimental setup. There, the mass difference and the intensity ratio is searched for in individual sample classes. As third experiment, we implemented the original X13CMS setup for a maximum of flexibility. Let's install DeltaMS. When you have started RStudio, click on Tools, Install Packages, and choose the package archive, and search for your downloaded DeltaMS file and press Install. You will see immediately that DeltaMS is installed. On the right-hand window, you can see now DeltaMS. If you like, you can use now also the user documentation provided in the package. When you type now library and in brackets DeltaMS, you can load the tool. Before you can start, you have to check for missing packages on your computer. With the command missing packages, you can check this and all missing packages will be installed automatically. After the installation process, which we have speed up here for the presentation, you can check again for missing packages. You will see that X13CMS is missing. By copy and paste of the website, you will be directly linked to the PattyLab homepage and can download the X13CMS package. Please install the X13CMS package as we have shown before. After a last call for missing packages, you will get the notice that all necessary packages seem to be present. Now we can run DeltaMS. Let's start from a new session. We start RStudio and type in the command line DeltaMS and run DeltaMS. Then a new browser window will open and we can start the analysis. First, we have to select a type of experiment. Next, we select a folder where the files we like to analyze are present. We choose now the file from our test dataset from case study 1. In case study 1, we have analyzed sulfur-containing compounds on a Q-exactive GC. Therefore, we type for the labeling of the isotope 1, 32 sulfur and 34 sulfur respectively. Now we can choose the two isotopes we like to find, which are again 32 sulfur and 34 sulfur. The value for the ratio deviation and the standard deviation for replicates we will keep as they are. On the top tab, you can, if you like, modify also the names of the generated analysis file. For a GC experiment, we prefer the matched filter algorithm for peak detection. All the other parameters for grouping, retention time correction, and the DeltaMS settings we will leave as they are. As you might have seen already, behind each parameter we implemented tooltips that you know what is meant with each parameter. Then you can start the analysis. Depending on the performance of your computer, the chromatographic runtime, and some other instrument settings, this will take a while. For data analysis, you must go to the folder where your file for the analysis is placed. There you will find a subfolder with the results coded with date and time. In that subfolder, you can find on the one hand a file with all analysis settings as HTML, the peak table as CSV document, and 4 PDF files. One file harbors the found features in absolute intensity values. Now you will see bar plots for features with DeltaMS have found. In purple you will see the isotope ratio which was searched for, and in blue bars those features are highlighted which fit the correct mass between both isotopes and the correct set intensity ratio. Bars in gray fit the correct mass but not the intensity ratio. On the next page, you can see further peaks where DeltaMS have found more sulfur in one compound. As second result file, we provide a bar plot with relative intensities. The third data evaluation possibility is the mass spectrum preview. With these images, you can easily review the data and you can see what is beside the blue marked peaks present. As fourth result file, we provide plotted EICs of the found features. Here you can easily rate the peaks according to their peak shape. If you like to save your settings for the next time, we implemented this feature with the button Save Current State. When you want to reload a previous setting, go to the button Load Former State and choose from the list. Press the button Generate Link and click on the new appearing link, which will guide you to a new browser window with the saved settings. You just have to define the folder with the file again. Then you can start the analysis again if you want. To stop DeltaMS, go to RStudio and press the tiny stop button. If you want to know where DeltaMS is saving your setting, you simply need to write DeltaMS and locate the local DeltaMS settings. A path on your local computer will be given where the settings are stored. If you like to see the same results as we get from DeltaMS with our case studies, you simply need to copy the content of the Shiny bookmark folder into your system-specific file path. Thanks for watching.